Welcome to Mutual Exchange Radio, a project of the Center for Stateless Society. I am your host, Zachary Woodman. Joining me today is Anthony Di Franco. Anthony works at the intersection of complex adaptive systems and computing and focuses on developing convivial technologies, decentralizing infrastructure, and increasing the agencies of individuals and communities. He is a co-founder and board member at Counterculture Labs, a group of biohackers in Oakland, California, where he founded the Open Insulin project, an effort to develop open technology for insulin production at a microbrewery scale and organize patient-led cooperatives to manufacture it. Additionally, he is currently pursuing computer science research on foundational technology to make software easy to create and modify for laypeople, built on declarative programming techniques together with techniques for representing uncertain information. I really wanted to have a conversation that highlights ways we can work around injustice caused by the state, ways everyday people working outside the political realm can make the miserable ways of living that unjust forces into obsolete. Anthony is one of those people doing that work. As many people know, especially if you're diabetic, insulin is extremely expensive in the United States and unobtainable for many poor people. The reasons for this are largely legal, ranging from the inability of Medicare and insurance companies to negotiate with drug companies to FDA regulation effectively barring the production of generics into the market. But rather than dwell on the world of policy as conversations about this and similar topics commonly do, I wanted to talk to someone who's actually doing something about it, someone who's inventing processes to make insulin readily available by allowing small groups and individuals to make it in small batches. We talk about this technology, its limitations, and the capacity of this sort of action for liberating people from the yoke of the state. So here's my conversation with Anthony Di Franco. Hello and welcome to this episode of Mutual Exchange Radio. I am your host, Zachary Woodman, and joining me today is Anthony Di Franco of Counterculture Labs. Hello, Anthony.
Hi, how are you doing?
So we're here today to talk about biohacking and the type of projects that you are involved in at Counterculture Labs and what their radical potential might be. So for a second, for the uninitiated, can you give us an overview of what Counterculture Labs is? What type of projects you guys work on?
Certainly. So Counterculture Labs is one of several biohacker spaces in the world and one of a few in the Bay Area as well. And we have a number of community-led projects there, and we provide access to equipment that's useful for scientific purposes in general and biological sciences in particular. And we've done work on soil quality testing for the community. We have a number of more ongoing projects, such as the Open Insulin project, which I'm involved in, and Kombucha Genomics project, also a project to make vegan cheese. And we also host two mycology meetups. So we have a pretty broad range of interests that we facilitate community around and provide access to equipment for that purpose.
Right. And for those who are unfamiliar, what is the whole goal of the biohacking do-it-yourself biology movement as you see it?
Well, I think it is an instance of the hacker ethic in action in general, which is just to make it as easy and as accessible as possible for people to pursue their own interests with respect to a set of technologies that is usually locked up behind the walls of big institutions, and to get creative with those, to solve problems with those, or to just, have fun and tinker around and learn.
So let's get into a little bit about what you're working on. This might be a good example of what biohacking is about and what spaces like Counterculture Labs are involved in with the Open Insulin project. So what's the problem you're trying to address? How are you addressing it?
Currently, both in the US and in the world, there's a fairly severe crisis in access to insulin. And insulin for many people who have diabetes, all people who have type 1 diabetes, is absolutely necessary for survival. So I think the crisis with access to insulin is also kind of emblematic of the broader issues in how healthcare works in the US and in the West, and how it's essentially controlled by oligopolies, and a lot of the official policies actually support the oligopolization of the products and services that comprise the healthcare economy. So we are trying to address that by making the knowledge and the equipment necessary to make insulin open source, and to, or on that basis, organize small scale local production of insulin.
So let's go into a bit more detail on the why this is a problem right now. You mentioned there are policies that are enabling corporate control of access to insulin through various pharmaceutical companies. What do those policies look like, and how do they constrain access?
First of all, there's so much complexity in the system that itself is kind of a barrier to people even understanding what is going on. So I can't really provide a comprehensive view of how everything works and what's wrong with it, but I can point out a few of the more egregious things. And focusing on the example of insulin will help to narrow it down a bit. But I think the kind of mistaken philosophical idea behind everything is the idea that because research and development costs in medicine are high, there's this idea that you need a big organization with a lot of surpluses to carry out that research and development, and that organization probably needs subsidies of some form. And then the next mistaken idea is that granting monopoly privileges is a economically efficient form of subsidy to give them. So it kind of starts with patents and goes on into all kinds of practices that tend to stifle competition. One of the most egregious ones is called pay for delay, which is something that is just kind of a flagrant antitrust violation in any other field of business. It's when an incumbent producer launches a perhaps frivolous, most likely patent-based lawsuit against a potential competitor, and then settles the lawsuit with an agreement to not compete for a period of an ostensibly limited time, but in practice a very long time, like a couple decades. So it's kind of like a backdoor way to just turn a large patent portfolio into kind of an arbitrarily long patent term on anything that you're making. And it's something that is really, again, just like a kind of flagrant antitrust issue. The Federal Trade Commission actually has a public webpage where they are calling out the practice and imploring Congress to take action against it. But this is the sort of logic that prevails everywhere. I think it's just the idea that healthcare is somehow different, and the corporations that are involved in providing various aspects of healthcare just need to be able to get away with murder, figuratively and literally, because they are somehow needful or deserving of privileges.
You mentioned some of the policies that are relevant here are intellectual property law being captured by corporations to get rents. That might surprise some people because insulin isn't the latest cancer medication, some new experimental thing. It's a relatively old drug. So how exactly do they go through being able to use intellectual property to still erect barriers to entry for potential rivals?
Well, I think, first of all, the patent terms being as long as they are, 20 years now, that long period of a monopoly, it serves as an initial subsidy that also lets that monopoly producer put into place all kinds of exclusive and often secret business arrangements, and generates a large surplus that that incumbent can use to go and lobby Congress and can use to launch these frivolous lawsuits and carry out all of these other tactics, and also just gives them a large marketing budget with which to make it very hard for people to even be aware of alternatives. So that subsidy that is ostensibly being used for, or is ostensibly intended to go towards research and development, actually isn't being used that way. And then it's used to put into place a broader structure of guarantees of rent than would just come from the initial patent monopoly. And so what you get out of that is the kind of system we have in the US, where there are not just pharmaceutical manufacturers, but pharmacy benefit managers and the pharmacies themselves and the insurance companies, and they all have secret and often exclusive arrangements with one another to completely eliminate any kind of market pressure from the business that's going on. So, for example, I myself use insulin, and every time I've changed jobs or gone from a corporate plan to an individual plan or whatever circumstance change in my life, I've had to switch brands of insulin and switch brands of test strips and so on, because my new insurance doesn't cover the brand that I was using because they've negotiated some sort of an exclusive agreement. And this actually in itself just harms a lot of people, because some people actually react very badly to certain brands of insulin, and there are only certain brands that are formulated such that they can use them. So it's that's another kind of idealization that the system makes that isn't true, that these are all kind of equivalent, and it doesn't really matter to anyone if you're using one brand or another, or if one manufacturer has an exclusive arrangement with one insurance company or anything like that. That's another way in which the harms of these kinds of arrangements is being ignored.
And how does biohacking help get around this problem?
Well, we're working at a small scale, and we are trying to see how to take the tinkering and the small scale proofs of concept that we can do in our labs and take them to just the next level, which is community scale production. And once we create the technology to do that, then it'll be economically possible, at least, for there to be thousands of manufacturers instead of just 3 manufacturers in the entire world like there are now. And with thousands of small scale manufacturers, I think it will be essentially impossible for these kinds of exclusive arrangements and anti-competitive practices to prevail. Even just demonstrating that it's economically favorable to produce at a small scale like that, I think will already undermine these arguments that say that global mega corporation oligopoly is the only way to do this. And then it'll also just undermine it in a really, not just the rhetoric behind it, but it'll undermine it in a material sense, because suddenly there will be all kinds of alternatives, and the people using the medicine will be able to, I think we're looking at structuring these as cooperatives if possible. So then the people using the medicine will actually be participating in directly in the governance of the organization that's manufacturing it. And if we do all of this right, then I think these perverse incentives that prevail will go away, and we can just prove outright that healthcare wasn't different from every other field of economic endeavor ever, and it does benefit from there being does benefit from the people who are using the products having a say in the business of how they're made.
Right. So importantly, the hope is not to just like have another provider of insulin who doesn't rent seek. The hope is to enable individuals and groups of individuals to produce it for themselves. Right.
Yeah, I think the groups of individuals is our focus right now. I think it'll be another set of technological innovations in automation and miniaturization before
Right.
it can be individuals in a routine sense, and not just a few very special individuals. But yes, I think the bottom line is that this isn't something that needs to be like, manna distributed from the gods. It's something that is very fundamentally straightforward to make, as much as any other technology of production is, and it's something that you can learn to do, and it's something that you can do economically at a reasonably small scale.
So let's go to some of the people who would defend the status quo of production. We can continue to play with insulin as a test example, but this would probably apply to other areas. Someone of more progressive persuasion might say, well, look, we need these larger corporations to comply with regulations to make sure the production of the drugs are safe. Individuals doing it on their own might screw up and subject themselves to harm. So this is sort of like a necessary paternalistic intervention. What would you say to that?
Well, I think that's kind of putting things backwards. The reason you needed these regulatory frameworks in the first place to ensure safety is that these large corporations don't really have any incentive to provide a safe product otherwise. If you have people producing in a cooperative way medicine for their own and each other's uses, then there's a very strong incentive to do it in a safe way, and you don't need a paternalistic form of oversight to try to ensure that from the outside. If I'm making insulin for myself, I have no incentive to cut corners and harm myself, because I'm the one who's going to suffer.
Right, but their problem is that they think that people just aren't capable of producing this type of thing without screwing up. Do you just think that's an overblown thing, or do you think people have a fundamental right to be able to pursue this?
Well, ultimately, it's a technical problem of doing it safely, and the knowledge of how to do it safely and how to test it to ensure safety is commodified, and it is the expertise of people who work in the profession of bioprocess. And this is a skill that people can learn, and it's not magic. It's not that big corporations have some sort of special way of doing this that no one else can imitate. They work at a larger scale, but the actual economical scale of production for a biologic drug is quite a bit smaller than the scale they're working at. I think we're looking at making bioreactors that have tens of liters of capacity, and when you're working at that scale, it's pretty easy for just an individual human to go and troubleshoot things, and you can use a common pump to move stuff from one place, one vessel to another, and so forth. Whereas if you have a 4,000-liter vessel, then just the problem of keeping everything in that vessel mixed and oxygenated is like a very complex engineering problem. So in a lot of ways, it's easier to do things at the scale that we're looking at doing them at. And I know there's this kind of, I think there is a kind of cultural ubiquitous
Fear.
belief that kind of vests these big corporations with an aura of competence that no one else can hope to imitate. But if you look at the technical reality, I think the opposite is actually true. It's just like easier to work at a small scale, because everything is just way more accessible to inspection and intervention that way, and you don't have to create these tremendously complex systems to work at a huge scale and ship things all around the world and so forth.
Thank you for listening to this episode of Mutual Exchange Radio. I just wanted to plug the center for a bit. If you're enjoying this conversation about how individuals can overcome the confines of the state, C4SS highlights this sort of thing all the time. For example, you can buy Kevin Carson's book, Homebrew Industrial Revolution, at store.c4ss.org. Anthony plugs that at the end, and it's pretty closely related to this conversation. Or you can buy any other of our books by our scholars, and if you don't want to buy them, you can find much of the content that they write on c4ss.org. We have a number of articles, blog posts, and studies on political philosophy, economics, and current events from an anarchist perspective. This show and everything else the center does would not be possible without our donors and patrons. If you want to support the show, you can go to patreon.com/c4ss.org. That's patreon.com/c4ssdotorg. I'll have more information about how you can help support the show and the bonus goodies you get for doing so at the end. But for now, back to my conversation with Anthony Di Franco. Well, let's dive into maybe what the technical aspect of what you do is. What does production of insulin at this scale actually look like?
Well, I think the most accessible analogy that I've come up with so far is it's kind of like a beer microbrewery versus a, massive big brand, because you're working with yeast for the most part. We are using E. coli for some purposes, but it's even kind of the same microbe that you're using to brew beer, and you're doing it in a vessel that is a lot like a brewing vat. It's got temperature and pH control, and you add a feed solution in, and you keep everything mixed, and you keep it at the right level of oxygenation for your purposes. And then you have these, let's say they're yeast for the moment. So you have a strain of yeast that, unlike in the beer scenario, has been genetically modified to produce another protein of interest. So in this case, we have our first system to make the first variant of insulin that we're working on. We have two microbes. One is producing a precursor protein, and the other one is producing an enzyme that converts that into insulin. And you just kind of put them in their vessel, and you feed them, and you let them grow, and they produce the protein. And then you need to purify that protein out from the growth medium that they're in. So that's where it diverges a little bit from a microbrewery, in that instead of just kind of pouring out the beer and maybe filtering it or something, the process of filtering, so to speak, and separating the insulin out from the medium is a little more complex. So we're looking at using a couple of different forms of chromatography for doing that. Those basically amount to passing the medium through a tube that either has a kind of a filter in it, or it's packed with beads of a material that the insulin will only stick to under certain conditions. But again, it's just kind of, at the end of the day, it's basic plumbing and pumps, and it's running a solution through something, and separating out one of the components of that solution. So it's not orders of magnitude more complex than say brewing beer in a microbrewery would be. And you can get very sick if you brew your beer wrong and there's methanol in it or something. And likewise, you can get very sick if you do something wrong in your insulin production. Again, it's a skill that you can learn, and if you have an incentive to do it right, which you really do in both of those cases, then I don't think you should expect too many problems or difficulties in doing it.
Right, and very few people think that there needs to be massive intellectual property law. Well, some people might think this, but very few people think there should be massive regulatory things supporting only Budweiser making beer.
Yeah, I mean, I think, especially anyone who has tasted one of the local brews,
Right.
Alongside Budweiser, like they might say, yeah, I want that local brew to exist. It would be a shame if I could only drink this other one for the rest of my life, right?
Except in this case, it's needing to pay your life savings just to get something you need to live versus being able to get it readily.
Yeah, exactly. So yeah, I mean, because there's, behind everything, there's this oligopoly, and then around it, there are all these layers of complex and often secret exclusive arrangements. And the result of that is that the list price of a month's supply of insulin, like I actually encountered this difficulty at one point when I was still in graduate school, and I had some delay in the paperwork going through for registering for classes, and my insurance was dependent on that. So it came time for me to go get my refills right at the turn of the quarter, and I went in and they said, "Oh, sorry, your insurance actually doesn't seem to be active, so it's going to be $2,400 for a month's supply." And I was like, "Well, I only make $1,600 a month as a graduate student, so what am I supposed to do here?" And fortunately, I was able to get it sorted out and get the paperwork through and get it covered eventually. But right then and there would have bankrupted me if I weren't in a fairly privileged position where I have access to this good health insurance. And the people right now who, for many reasons, don't have really good top tier health insurance, like they often just can't afford their insulin. They're hit with a huge deductible, and if they get it covered at all, and there's people who like age out of their parents' plans and then they aren't able to obtain insurance as individuals, and on and on. There's such a complex system with all these bureaucratic gotchas that we have here, and people fall through the cracks of this complex system, and then they die because this list price is so inflated that few can afford it. Very few could actually afford it, and everyone else is not just out of luck. They're dead, frankly. So
Right, and this is rather than sitting back and waiting for Congress to pass some law to get the cost of pharmaceuticals down, you're saying take direct action and try to provide this thing for the people themselves.
well, yeah, I mean, I think it we're actually have been approached by some folks in Congress who want to facilitate what we're doing, and they realize that the politics around the usual questions of price controls might be very difficult. So it might be necessary to try to pursue a diversity of strategies here. But yeah, I mean, we saw some legislation, for example, in Colorado that looked like it was going to be instituting price controls, and in the end it only really helped a very narrow section of the population, the one that didn't really have much of a problem anyway. Just capped the copays for insulin to $100 a month, and that means you already have insurance and you already can probably afford it, and it's just going to reduce your costs a little bit. But and I think this is extremely galling because you have a cartel that is already pretty obviously fixing prices. It's been accused in a number of lawsuits of colluding to fix prices, and there's pretty good evidence out there that that's going on, enough to go forward with these lawsuits. And you can just look at the record of price increases over the last couple decades, and it's happened that they've gone up by the same proportion at the same time, almost perfect synchrony every few months for decades. So it's really hard to ignore that kind of evidence, and yet so price fixing is fine if it's done for the benefit of the cartel, but if the government were to come in and fix prices, it's like a huge political problem to try to advocate that. So there's
Not to
some.
mention those price controls can produce shortages and dead weight loss and all the other things associated with it.
Oh yeah, I mean, but I think you're already seeing that from the oligopoly, and then
Well, right.
I don't think it would be improving things necessarily to have price controls, because again, I think the businesses on the other side of that probably have the flexibility to sabotage whatever benefit that would ostensibly generate. Ultimately you just need there to not be a cartel. I'm sure they would have a pretty devastating response to price controls, even if strong price controls were to
Anyway,
be instituted.
so stepping back from insulin, one might think, well, with something like insulin, this drug that was sort of developed in the 20s, right? It's not that complicated to make. Like you said, it's just slightly more complicated than like brewing beer. But they might think, well, for other more modern, technically challenging medicines, nothing like this could ever possibly substitute what, the capitalist corporations can provide. How far do you think this type of biohacking can spread as a supplement for the status quo in medical care?
Well, actually, the techniques that we're using to make insulin now are the state-of-the-art techniques to make biologic drugs. So that's about as complicated as it gets. So this is the insulin that was made in the 20s was extracted from animal pancreas, and from the 20s to the 80s, that was the only way to do it. But then in the 80s, the first generation of insulin that was produced in genetically modified microbes came to market, and around the 2000s, there was a second wave of insulins that have longer and shorter acting kinetics. So they're kind of more precise tools to use to control your blood sugar, and that's the state of the art right now. And that's what we're making, and we're using the state of the art techniques to do that. So, and engineering a microbe to make a drug is a little bit, I think it depends a lot on the details, but it's usually more sophisticated than making a small molecule drug that you can just do with like a series of chemical reactions. And there are even some cases of drugs where you have to do, you engineer a microbe to make one thing and then you chemically modify it later, and you can get into some complex processes. But we're basically already at close to or at the frontier of sophistication for how complex a drug manufacturing process can be. So in a way, we've already gone right up to the top and shown that this is possible to do at a small scale.
So besides Open Insulin, what are other projects that Counterculture Labs are working on?
Well, another project that I think is very interesting and that would have a lot of implications is the vegan cheese project. So that is working with a similar set of techniques that the insulin project is working with, but instead of making insulin, the proteins that they're making are milk proteins. And this is kind of the missing element in being able to make artificial milk that would be just like animal milk, because once you have these milk proteins, then you just add some sugar and some fat alongside that, and you could get those from vegetable sources as well, and then you should have something that is very much like animal milk, but it'd be produced only with non-animal sources. So that could be a lot more economical than having a whole cow and a whole army of cows on a huge feedlot and holding them and
The
often
dozens of acres of corn it takes to feed them.
yeah, the whole thing. Yeah, you just shortcut out a lot of that, and you kind of eliminate all of the suffering and waste that is associated with that. You just kind of get right to the point and you make your milk. That is something that a lot of actually private startups have tried to do, but the only enduring effort to do this that has been able to make consistent progress I know of is our completely open project. So in that case, I think it's just the fact that there are a lot of really hairy technical challenges involved in making this protein and then having it stay in the right fold correctly and be in the right condition that you could go and make milk and then cheese with it. And it requires a lot of patience, and it requires a lot of kind of elbow grease, and it's not something that like a venture funded startup that is just trying to hit a home run in a few years is going to be able to do. It's actually a deeper problem than you can really realistically solve with the short time horizons of the kind of capital that funds these ventures.
Are there similar issues of regulatory capture that you encounter in that project?
Well, it's still the FDA would be involved in some way again. And actually, I'm not directly involved in that project, so I don't recall exactly the way this conversation went. But there's a question of, would this be considered a genetically modified organism? Would this be considered some sort of a food additive? How do you classify this? It's not a whole lot like anything that anyone has done before. And then, the way in which it's going to get classified is going to determine what kinds of regulations people try to apply to it, and what economic implications that has, what implications it has for the viability of a business that's going to actually make the cheese and so on. So yeah, I mean, in a sense, it's similar in that there are a lot of these really complex questions that you have to try to navigate, and you're doing things in a way that are kind of unprecedented in a lot of ways, and the system doesn't really have a clear pathway set out for you. And so, that's just kind of an inherently conservative element of, I think, a bureaucratic regulatory system, is that it can only kind of look back at how people have done things in the past and what people are doing in the present, and it can't really anticipate how things will be done in the future and leave the door open for there to be like a clear pathway to doing new things. So there's kind of this inherent conservative bias to that kind of a regime. And that's something that we're facing because we don't really know exactly how the insulin would be viewed by the existing regulatory system. And, every expert we talk to has a slightly different take on what it might look like. And, we're trying to have our lawyers sort through all of that, but it's just kind of complex. And ultimately, I think we might actually need to work with our allies in Congress and just say, like, look, this is a new thing and this is how it's going to work. And, try to cut the Gorgon knot there. But, a lot of these issues, I think, are just, you create a system that is very complex and very bureaucratic, and that in itself means you need tons of money and, fancy lawyers to even figure out what you're supposed to do in the first place.
Yeah, those are barriers to entry erected by the state. So what do you see as the potential of this sort of biohacking for society at large outside of these isolated cases?
Well, it's clear to me that these kinds of technologies are going to continue to be more and more fundamental to how food and medicine are made. And if we succeed and we make the equipment and the knowledge necessary to use these technologies widely available and open source and ubiquitous, then that means that the benefits of food and medicine will continue to be widely accessible and widely shared. And I think, it's not really clear in any of the specifics yet, but I think there could be like a really a historic crisis in the making if these technologies continue to be really closely held and closed off, because you're going to have very powerful oligopolistic institutions that don't really have any incentive to care about people's well-being in general. They're able to, being as they're operating as monopolies and oligopolies, they make most of their money off of a fairly small clientele, and they just kind of need to work with, a small set of cronies to keep themselves propped up in the positions that they are. And, that means that the welfare of society in general is going to be lost, and if you let that kind of a system prevail.
And this is a way around it. So what are the types of problems that you've run into running a lab like Counterculture in terms of implementing your vision?
Well, the main ones have just been really kind of mundane, and it's been, you're trying to keep people consistently involved and contributing and happy when everyone's a volunteer and everyone kind of has the pressure from, their day job or whatever it is they have to do to make a living. And, that most fairly quickly takes most people who otherwise would be interested in would be serious contributors, and it takes them away from us, a couple weeks or a couple months into their tenures. And it's really hard to to keep the momentum behind a project when there's a lot of turnover and when people are stressed out because they have to, do something completely different to pay the bills. And you really see how much of an impediment to people doing things that would really be valuable to society, having to go and earn a living in the wage economy is.
Right. So a question I always like to end these interviews with is, are there 3 books or pieces of reading material on anything we talked about that you'd recommend if people want to learn more about what Countercultural Labs is up to? It could be documentaries or whatever, ballets, but about what Countercultural Labs is up to, what the potential of this technology is, and how people could get involved.
Sure. I don't know if people have written too many books that like really look at biohacking per se and capture what it's about, but there are a few recommendations I have just kind of on the I think the philosophical background that would lead someone to a project like this. One of them is Ivan Illich's Vernacular Values. I often come back to that one, and that's kind of about the history of kind of organizing society in a way such that people are dependent on institutions for their basic needs. And when we're looking at the questions of food and medicine and the way that we're looking at them, and I think he does a great job of framing that in terms of what interests people on the other side of that had in keeping people's ability to meet their basic needs away from them and making them dependent on institutions. And let me see, really getting back to the point, there's this will be much more down to earth. The book is called An American Sickness, and the author, I believe, is Elizabeth Rosenthal. It's Elizabeth Rosenthal's book, An American Sickness, and that goes into a fair amount of depth about all of the pathologies of how healthcare works, or rather doesn't work, in America, and all of the complexity that has been, it's kind of malicious complexity that really just serves to make the operations of the system opaque and make it hard for anyone to criticize or change the system. And this starts to kind of peel away at the layers of the onion a little bit and show what is really behind that, and how it's harmful. And the third one, it's actually someone who is one of your comrades over at C4SS, Kevin Carson's Homebrew Industrial Revolution. I actually think that is a great book to understand how small scale distributed technologies of production and networks that grow up around them can actually be the most economical alternative and preferable in just about every sense. And I think I haven't gotten around to reading it yet, but he also wrote The Desktop Regulatory State, right, which is start addressing some of these questions of, how do you make it safe if there isn't this, it's not really a question of making it safe. Again, it's a question of like, why is it safe regardless? But, gets into the meat of that question.
It's an Onstromian project to try to explain why social coordination works, where theoretically it seems like it shouldn't.
Yeah. Oh yeah, that reminds me. Like Elinor Ostrom. Read a bunch of Elinor Ostrom too.
Yeah. Yeah. Everyone should read that. Anyway, thank you for coming on the show today. This was an informative conversation, and I learned a lot. Thank you.
Yeah, thanks for having me. It's been a pleasure.
Thank you again for listening to this episode of Mutual Exchange Radio. I'd like to thank Anthony for coming on and having such an enlightening discussion. As I mentioned earlier, if you like this show and want to support what we do, you can support us on Patreon. If you decide to do so, you get special bonus content and swag as a thank you for your support, including books, bonus episodes like a recent conversation on the foundation of the center, free buttons, zines, and other swag depending on how much you donate, as well as special credit at the end of the show. If that sounds appealing to you, or if you just want to support us on having these types of conversations, You can go to patreon.com/c4ss.org. That's patreon.com/c4ssdotorg. And here's a special thank you to our current associate producers: Stacey Jamal, Wendy Stoileroff, Derek W., David Colburn, Acknarls, Cecil Leon, Richard, DT, Sam, Jacob Sykepin, James Tuttle, and Alex Gutowski. Thank you for listening, and I hope you will join us next time on Mutual Exchange Radio.